in the UGC net economics paper of August 2024. The question is, if the production function is, that is f of Lk is equal to L times K divided by L plus K, where L and K denote the units of labor and capital, we have to find out the degree of homogeneity for this production function. Okay, so first we should know what is meant by the production function, what is meant by the homogeneous function. Okay, so we say a function, let us say f of xy is homogeneous of degree k if, that is, if I multiply each of the variables by lambda. Let us say lambda x is multiplied by lambda, and y is also multiplied by the same factor lambda, let us say lambda y, and if we get the relation like this, that is lambda raised power k times the ordinal function, that is f of xy, we say this function is homogeneous of degree k. Okay, so k denotes the degree of homogeneity. That means we are being given the production function here, this very production function. Let us increase each of the inputs by a factor lambda. That means if I write it like this, f of lambda L lambda k, so if I multiply each of the factor by lambda, so in place of L we will have lambda L, and in place of k we have lambda k, divided by, similarly in the denominator, in place of L we have lambda L, plus in place of the k we have lambda k. So can we rewrite it like this, lambda into lambda is lambda square times Lk divided by, let's take lambda common here, we are left with L plus k. Okay, so one lambda gets cancelled, we are left with lambda times Lk divided by L plus k. Okay, so lambda, here we have the power of the lambda is 1. So you can see what we get here. So f of lambda L lambda k came out to be lambda raised power 1 times this Lk upon L plus k. This is our ordinal function, that is f of Lk. That is, we got the given function as the degree of 1, and it is also homogeneous. Okay, so the degree of homogeneity for this question or for this production function is 1, because the power of the lambda is here 1. What exactly is meant by this? It simply tells us if we increase, okay, if we increase both labor and capital by a factor by a factor lambda, output will be increased by lambda raised power 1. Okay, so this denotes our degree of homogeneity. So this function is homogeneous of degree 1 here. Next question is, if y is equal to 1 plus x divided by 1 minus 2x, find dy upon dx. That is, we need to differentiate this function with respect to x. Okay, so here we have to apply the quotient rule. Let us say this, what we call the numerator, let us say it is our g of x, let us say the denominator is f of x. Okay, so what does the quotient rule tell us? If we have a function, let us say h of x is equal to g of x upon f of x, if we have the two functions, then the derivative of this h of x, let us denote it by h prime x, its derivative is simply equal to, first we write the denominator function f of x and multiply it with the derivative of the numerator function, that is g prime x. Then we subtract and write the numerator function g of x and multiply it with the derivative of the denominator function, that is f prime x, and we divide it by the denominator function, that is f of x, but we whole square it here. Okay, let us say y is our h of x. Using this stuff we can solve the question. So dy upon dx in this question will be equal to, so first we write f of x as it is 1 minus 2x and take derivative of the numerator function, that is d upon dx of 1 plus x. Then we subtract and write the numerator function, that is 1 plus x, and take the derivative of the denominator function, that is d upon dx of 1 minus 2x, and divided by the denominator function, which is 1 minus 2x whole square. Okay, now solving this here, it implies, so let me write it here. Here we have, let me write it, I don't have the space here, and let me try to put it here. So we have 1 minus 2x, derivative of a constant is 0, derivative of x is 1, so we are left with only 1 here. Then we have minus 1 plus x, 1 plus x, derivative of constant is 0, derivative of x is 1, so we are left with minus 2, and we divided by 1 minus 2x whole square, so it will become, so we have 1 minus 2x, then we have minus 2, and let me write it here, minus 2, or let's write it like this, we have minus 2 into 1 is minus 2, then we have minus 2 into x is minus 2x, divided by 1 minus 2x whole square, so it will become, so we have 1 minus 2x, so minus into minus is plus 2, then minus into minus 2 is plus 2 again, x, divided by 1 minus 2x whole square. So plus 2 and minus 2x gets cancelled, then we have 1 plus 2, which is 3. So we will get here 2 plus 1 is 3, divided by 1 minus 2x whole square. This will be the derivative, that is dy upon dx will be equal to 3 divided by 1 minus 2x whole square here. Okay, so simple thing what we are doing here, when we have a function in this form, that is we have two functions in numerator and denominator, what we write, so we take we write the denominator function first and take the derivative of the numerator function, that is we write the denominator function first and differentiate the numerator function with respect to x, then we subtract and write the numerator function first and we multiply it with the derivative of the denominator function with respect to x and divided by the by the denominator function but raised power to the 2. Okay, question is, if the demand function is q is equal to 20 upon p, where q is the output, p is the price, when price is less or equal to 10 and marginal cost is equal to 1, we have to find out the profit maximizing level of price and output. Options I don't remember, but I will try to solve this question here. Okay, so what we are being given here, we are being given the demand function, and let me write it here, q is equal to 20 upon p. This is our demand function. Now if I transpose this p, it gets multiplied, so p into q is equal to 20. We know that price into output is total revenue. Can I write total revenue is equal to 20? And we also know that profit maximizing condition requires that we equate the marginal revenue with the marginal cost. Marginal revenue, let us try to find out. Marginal cost is being given us here, that is 1. Okay, so to find out the marginal revenue, we differentiate the total revenue with respect to output, that is our marginal revenue will be the derivative of the total revenue function with respect to output, which is q. So this is our total revenue, its derivative with respect to q. Since we have no q here, it is a constant here, so the derivative of total revenue function with respect to output gives us marginal revenue, which will be equal to 0. Okay, derivative of 20 is 0 here. Now using the profit maximizing condition that marginal revenue is equal to marginal cost, that implies our 0 should be equal to, marginal cost is being given 1, but it is not possible here. That means this method of applying marginal revenue with marginal cost is not feasible here. It will not give us the profit maximizing what we call price and output. Okay, now what here we actually need to do, let us find out. So Q is equal to 20 upon P. So Q is equal to 20 upon P. Rewriting this, that means P into Q is equal to 20. What does this function tell us? P into Q denotes the total revenue. Here we have a constant total revenue function because P into Q is equal to 20. So we have a constant revenue function. Whenever we have a constant revenue function, and in this case, what will be the profit maximizing price and output? That is simply with when we are being given the constant total revenue function, firm will charge, and let me write it here, firm will charge highest possible price. That means firm will charge highest possible price with lowest possible output produced. Okay, firm will charge highest possible price and produce lowest possible output. Let us see what will happen here. So we know that P into Q is equal to 20. Now what is the highest possible price that the firm can charge? We are being told here price should be less or equal to 10. So price cannot be 11 here because of this constraint. So the highest possible charge that the firm can charge in this case will be equal to 10. So if here we have 10, so 10 into, in place of Q, what will be the value of Q? So that 10 into some variable gives us an output of 20. So what will be in this box? 10 into, since price is 10, what will be the output? So the total revenue is equal to 20. You can, by trial and error, it is very simple. 10 into 2 gives us 20. Okay, so let me write it here. So 10 into 2 will give us 20. That means the highest possible price, and I will explain this with an example how it happens. So profit maximizing price will be equal to 10 that the firm should charge, and profit maximizing output should be equal to 2 here. Okay, now let me explain it with an example why this is case, why this 10 gives us highest possible why this P is equal to 10 and Q is equal to 2 gives us the highest profit. Let us do some simple example. We know that profit is equal to total revenue minus total cost. Okay, total revenue, as you know, is simply equal to price into output minus what is the total cost? That is the integral of the marginal cost function with respect to output. Here we assume fixed cost is equal to 0, and let me explain it here. So our profit will be equal to P into Q minus derivative of marginal cost is 1. So let's write it here 1 this time. The integral of 1 is Q here. So we will get Q plus the constant of integration here, and we assume the fixed cost is equal to 0. We will not write the constant of integration. So this is our profit function. Now let's take this price which we calculated as 10 and output as 2, and let us find out the corresponding profit. What will be the profit? And let me write it here. When P price is equal to 10 and output produced is 2, profit will be equal to, so profit will be equal to 10, P is 10, output is 2 minus Q is 2, which is total cost. So 10 2s are 20. Here we have 2. So profit is equal to 18. Here you can check it by yourself. Now let us take any other price other than 10. Let us take P is equal to, when, let us take an example when P is equal to 5. If P is equal to 5 in this equation, since P into Q is equal to 20, if we take P is equal to 5, what should be value of Q? So that total revenue is equal to 20. So Q should be equal to 4. Okay, when P is equal to 5, Q is equal to 4. Let us find out the corresponding profit. So profit will be equal to price into output. That means 5 into 4 minus Q is equal to 4. So it is 20 minus 4, which comes out to be 16. Okay, here you can see profit has decreased when we charged less price than 10. Okay, so the logic is pretty simple. Here if you can see see this example, it is actually a rectangular hyperbola demand function. Okay, so another important property of this function is that we have the unitary elastic demand function. That means elasticity of demand will be unity irrespective whatever is the price or corresponding output. So for this demand function, price elasticity of demand will be 1 at any point on the curve, because we have a rectangular demand function here, right? What we call the rectangular hyperbolic demand function. Okay, so I hope I make myself clear. But I have found some YouTube channels trying to copy these very videos into their PDFs. They take the screenshot of these videos. Okay, that really discouraged me to make more videos, because I am doing all this stuff for free. And if some YouTube channel, or I will not take the name of that very YouTube owner, which has taken the screenshots from these videos and made an PDF for the numericals. So but I hope you people can recognize that very person, because someone has inboxed me about the videos that I post and how they are being manipulated, they are being used for commercial purposes. So I will request those very people not to use my content for their commercial purposes. Okay, I hope I make myself clear in this video and you find out this video helpful. Thank you.